Here we want to graph the polar equation. First, let's use two different technologies to graph this one. Again, by TI-84, you first want to do is input the polar equation. Again, one more time. Here, when you turn on your calculator, it might be at this mode, at this state. So when you click on y equals, you may not really get R1 equals. What you get might be mode. Move the cursor right here. Hit enter. The function was previously in polar, now is in function mode. Now when you hit that, is y1 equals. That might be your state. If you want to get it back, you want to click on mode. Move the cursor down to polar. Later on, here is parametric. We want to do that later. But here is polar. Hit the enter. This one highlighted. And then when you do that, this one shows up. That's a kind of repeating lecture I did. And then you may do 3 divided by, click on 3 divided by, do not forget the parentheses, okay? And then 1 minus sine theta, double brackets. And when you graph it, it's going to get a parabola with the open direction upward. So you see, here is a parabola. You may zoom out a little bit. Click on window number 3. So you will see that's a parabola with open direction upward. And then down here, that's a hyperbola. And the hyperbola in horizontal way. This one sounds right, and this one is a parabola, but open direction is to the right. So that would be this one. Now, we will also use what? Decimal. You do is R equals 3 divided. You want to put the parentheses first, in case you forget. And here, you may not even need the parentheses, because you just need to input sine theta. You will get the picture. Okay. So that's a parabola. Okay. And then that's using the technology is quite fast. How about algebraic way? Here I'll show you the algebraic way. Again, you want to use 3 identities. X equals r cosine theta, y equals r sine theta, x squared plus y squared is r squared. You first want to write the equation r equals 3 over 1 minus sine theta. You copy this one. We do not like denominator 1 minus sine theta. Both sides multiplied by 1 minus sine theta. And then you cancel 1 minus sine theta. You have a right-hand side is 3 stands alone. Left-hand side is r times 1. You have r times negative sine theta. You have a negative sine theta. Now you want to get, this is the new equation we get. It's r minus r sine theta equals 3. That's a new one. Now you want to take r sine theta to the right hand side. So you add r sine theta on both sides. The left hand side you will have r stands alone. Right hand side is 3 plus r sine theta is y. So that's why you have a y plus 3 from here. Left hand side, you then have r stands alone because those two are cancelled. You then square both sides. Okay, r plus 3, you square it. And here you have r, you square it. R squared is x squared plus y squared. That's this identity. R squared is x squared plus y squared. And this one, y plus 3 squared, is y plus 3 times y plus 3. And then you can FOIL this one out. Y times y is y squared. Y times 3 times y, so you double 2 times 3y, and 3 times 3 is 3 squared. Both sides have y squared, so if you subtract y squared on both sides, they will disappear. And the left hand side, you have x squared stands alone. Right hand side, you have a 2 times 3, which is 6y, plus 3 squared, which is 9. Up to this far, you will see that's what? That's a parabola. You may go further. As both sides subtract 9, you then have a 6y stands alone on the right hand side. Left hand side is x squared minus 9. You put on the right hand side, and both sides divided by 6. You have a y stands alone on the left, equals right hand side is 1 over 6 x squared minus 9 over 6, which is 3 halves. This would be the equation for parabola. You can see the vertex is where? Is 0, negative 1.5, or 0, negative 3 halves. Again, by the decimal, you can put what? 0, negative 3 halves. This would be the one. This would be the one. That's vertex. Okay? So you can use technology either by TI-84 or TI-83. And here you can also do by decimal. And here is the third method, which is by algebra. Algebra is actually the way we want to understand. But right now we have a technology, so you can easily find out the graph. All right, I'll see you next time.